Section 1.5, scalars and vectors. We're going to see how to distinguish between these two different terms, what it means to be a scalar versus a vector. So to introduce this, back in 2009, Usain Bolt set a world record of 9.58 seconds for 100 meters, which I just think is wild. Like, I think it would take me 100 seconds to go 100 meters, not less than 10 seconds. So incredibly fast. But in this instance, all that really mattered was the time. It's just a number that mattered, the 9.58 seconds, right? It wasn't anything about where he ran it, though that's a detail you could look up. And so this gives an example of a scalar quantity. So a scalar quantity is something that can be described by a single number, again with units, because we have to keep our units, they're too important. So temperature, speed, mass, or time are all examples of scalar quantities, where there's just a number and a unit, and that's all. Things get a little more complicated in contrast with vector quantities. So a vector quantity deals inherently with both magnitude and direction. So velocity is one example, where velocity has a magnitude, which is speed, how fast something is going, but also where it's going. Force is another one that we'll see a lot of, or displacement, which says both how far you've gone, the distance, and the direction that you've gone. So let's look at an example here, because this helps to highlight it. The car moved a distance of 2 kilometers. At this point, it's just a scalar. We know that the car's gone 2 kilometers, but where is the car? We don't actually know. There could be any range of possibilities, but we could get more specific, and we could say, hey, the car moved a distance of 2 kilometers, 30 degrees north of east. Now that we've filled in that direction, we can know exactly where that car is, right? We could figure this out, that 30 degrees north of east, so going up above the east, and we're 2 kilometers away from where we started, the car must be exactly there. Versus before we had that 30 degrees north of east, the car could have been anywhere on this circle. We just know it went 2 kilometers away from where it started. And that's assuming that it traveled in a straight line. So the direction helps us out quite a bit. Vectors, it turns out, are really useful to physics. Let's take a closer look at how we use vectors. So we'll use arrows in order to represent vectors, and the direction of the arrow tells you the direction of said vector, that it's pointing up that way, or to the right, or to the left, right? The arrow points in the direction of the vector. And by convention, the length of the vector arrow is also proportional to the magnitude of that vector. So here's one that's 4 pounds, and it has some length, and if it becomes 8 pounds, it is twice as long because the magnitude is twice as big. So the length of the arrow can help show the size, while the direction gives the direction. Cool. So this sets us up for understanding the difference between scalars and vectors. Let's look at an example where we're going to check our understanding to see which of the following statements, if any, involves a vector. So you'll be able to vote for A, that it is a vector, or B, it is not a vector. So I'll pull these all up on the screen, but I want you to figure it out before you move on to get the final answer. So I walked 2 miles along the beach. I walked 2 miles due north along the beach. Let's pause right there and take a look, right? So the first one, I walked 2 miles along the beach. We know the distance, and if you knew the beach, you might know that it was, you're walking, say, north or south, but we don't even know if it's north or south here. So this is one that I would say is not a vector, right? But in contrast, look, when we have 2 miles due north along the beach, cool. Now we have direction, so that is a vector. Let's look at another one. I jumped off a cliff and hit the water traveling at 17 miles per hour. Think for a moment. Do you think this is a vector or not a vector? Let's look at a couple others. I jumped off a cliff and hit the water traveling straight down at 17 miles per hour. And finally, My bank account shows a negative balance of negative $25. All right, so I want you to think through these last three and come up with answers to them before you move on. So go ahead and pause the video now. All right, did you do that? I'm hoping so. So taking a look at this, when you jump off a cliff and hit the water traveling at 17 miles per hour, this one's a little tricky because we know that we generally will fall down. So you might assume that this suggests the direction is down. But it doesn't say the direction you jump. If you jump at all outward from the cliff, then you're going to hit the water going down, but also going outward still. So this is one that it doesn't specify for sure which it is, so I'd say not a vector. But in contrast, when you say it's traveling straight down, that straight down now gives us a direction. So we can say, yes, this is indeed a vector. Cool. What about this last one? This one's a different one. My bank account shows a negative balance of negative $25. Well, it sounds like you've gone down negative $25. So it sounds like you potentially have a direction. But do we know that? We don't, right? You might have had actually a negative balance of negative $100, and you've actually worked up to this point where negative 25 isn't so bad. All that we know is this data point, this exact location of negative $25, but we don't know how you got there. So that is one that I would say is not a vector. So hopefully this introduces the difference between our scalars and our vectors. Vectors are basically scalars with a direction added on. So I hope that helps. I'm happy to talk about more if you want to. So let's keep digging in. We will have much more to come with vectors.